Now, in this lecture, we shall study the water system. Discussion of some important heterogeneous systems from the standpoint of the phase rule. The water system. Water can exist in three possible phases: solid, liquid, and vapor. Hence, there can be three forms of equilibria: liquid vapor, solid vapor, and solid liquid. The curve OA in this figure represents the equilibrium between water and vapor at different temperatures. It is called the vapor pressure curve of water, as it gives the vapor pressure of water at different temperatures. It can be seen that for any given temperature, there exists one and only one vapor pressure. Similarly, for each vapor pressure, only one temperature can be maintained. Thus, the degree of freedom of the system is 1. That is, the system is univariant. So, this is predicted by the phase rule. F is equal to C minus P plus 2 is equal to 1 minus 2 plus 2 is equal to 1. At 100 degrees centigrade, the vapor pressure of water equals the pressure of atmosphere, 760 millimeter. This is therefore the boiling point of water. The curve OA extends as far as the critical temperature of water, 374 degrees centigrade, since above that temperature liquid water cannot exist. The curve OB represents the equilibrium between ice and vapor. It is called vapor pressure curve of ice or sublimation curve of ice. Its lower and B extends to absolute zero. Again, as can be seen, for each temperature there can be only one and only one pressure, and similarly for each pressure one and only one temperature can be maintained. In other words, the degree of freedom is again 1. Thus, the vapor pressure of water increases from 634 millimeter to about 760 millimeter when the temperature changes from 95 to 100 degrees centigrade. Since along OA the two phases are liquid and vapor, and along OB the two phases are solid and vapor, at the point O where the two curves meet, three phases, namely solid, liquid, and vapor, will coexist. Such a point is known as the triple point. The temperature and pressure at the triple point of water are 0.0098 degrees centigrade and 458 millimeter respectively. According to phase rule, O is an invariant point, the degree of freedom being 0. F is equal to C minus P plus 2, one component system, so 1 phases are 3, solid, liquid, and vapor, 3 phases are there, so 1 minus 3 plus 2 is equal to 0. The curve OC represents the equilibrium between ice and water. It is called the fusion curve of ice, as it indicates the temperature and pressure at which the solid and liquid any solid means the ice and liquid water can coexist in equilibrium. In other words, the curve shows the effect of pressure on the melting point of ice. It may be mentioned here that the freezing point of water and atmospheric pressure, which is taken at 0 degree centigrade, is in fact the freezing point of water containing dissolved air. The presence of air lowers the freezing point of water by about 0.0023 degrees centigrade. Along the curve OC there are two phases, namely ice and water. Therefore, according to phase rule, the system should be univariant, that is, the degree of freedom should be 1. This is seen to be actually the case, as for any given pressure, melting point will have one definite value. The curve OC must meet the other two curves at the triple point O. To sum up, along OA, water and vapor; along OB, ice and vapor; and along OC, ice and water coexist in equilibrium. At point O, three phases, namely ice, water, and vapor, coexist and therefore the system becomes invariant. That is, its degree of freedom becomes zero. In other words, these three phases can coexist in equilibrium only at a definite temperature and pressure represented by the point O. Therefore, neither temperature nor pressure need to be mentioned to describe this point. The very statement that all the three phases of water coexist is sufficient to define the system completely, as this is possible only at a definite temperature and pressure. Now, significance of areas or regions between the lines. Suppose the state of equilibrium is represented by a point X on the line OA. You can see this in the figure. The two phases in contact are liquid and vapor. If the temperature is kept constant and pressure increased, the vapor will be compressed whole into the liquid phase. This change is represented by the dotted line XB, you can see in the figure. Similarly, if pressure is kept constant and temperature is decreased, the vapor will change into liquid again. This change is represented by the dotted line XC. Thus, the area above the curve OA represents exclusively the liquid phase as shown. You can see the figures. Coming back to the point X, if the pressure is maintained constant and the temperature is increased, the liquid will change completely into vapor. This change is represented by the dotted line XY. Similarly, if the temperature is kept constant and the pressure is diminished, liquid will again be converted completely into the vapor phase, as represented by the dotted line XZ. Thus, the area or region below the curve OA represents the vapor phase only. Similarly, if a system represented by a point S on the solid vapor equilibrium curve OB is subjected to increase of temperature at a constant pressure along ST or decrease of pressure at a constant temperature along SU, it will change completely into vapor. This you can see in the figure. Thus, any point lying below the curve OB also represents the vapor phase only. Lastly, if the system at S is subjected to increase of pressure at constant temperature along Sm or decrease of temperature at constant pressure along Sn, the vapor will condense completely into solid phase. Thus, the area lying above the curve OB will represent the solid phase exclusively. Now, salient features of the water system. The salient features of the equilibrium diagram of the water system may be summed up as under. The curve OA is the vapor pressure curve of water. Hence, here water and its vapor coexist in equilibrium. As the number of phases is 2, the degree of freedom is 1, that is, the system is monovariant. The curve OB is the vapor pressure curve of ordinary ice. It is also known as the sublimation curve, as the solid phase ice is in equilibrium with vapor. The system is again monovariant. The curve OC is called fusion curve, as here ice and water coexist in equilibrium. The system is monovariant. This curve gives the effect of pressure on the melting point of ice. It is inclined slightly towards the pressure axis, which indicates that the melting point of ice is slightly lowered by the increase of pressure. The curve OA dash is the vapor pressure curve of metastable water. The curve O, where the three curves OA, OB and OC meet, is the triple point where the three phases ice, water and vapor coexist in equilibrium. The system represented by this point is non-variant. The vapor pressure at this point is 4.58 millimeter and the temperature is 0.0098 degrees centigrade. The area bounded between the curves gives condition of temperature and pressure under which a single phase, that is either ice or water or vapor, is capable of suitable existence. Thus, in the area lying between the curves OA and AC, water alone is capable of stable existence. Similarly, in the area lying towards the left of the curves OB and OC, ice alone, and in the area lying below the curves OB and OA, vapor alone is capable of stable existence. In all these regions, the degree of freedom is 2, that is, the system is bivariant. In the next lecture, we shall study the carbon dioxide system and the sulfur system. Thank you.